The border problem is going to be tricky just because the setup can be a little complicated. So let's talk about how to get this problem set up, and then like we did with the farm example in the other video, we'll use our graphing calculator to actually solve it. But the setup, I think, is what I want to focus on because, like I said, that can be the tricky part. So here's what is going on in this case. Basically, if you remember back from geometry, we're working with one of these shaded region problems. I want to find the area of this border of this rectangle. Okay, so if you recall from geometry, the way that we found the area of the shaded region was we looked for the area of the bigger rectangle. So I'll say area of the big rectangle. And then I want to subtract off the area of the small rectangle. And then what's left behind is going to be just that frame or just that border. So that's going to be our thinking as we set up this problem. So what we have is we have a quilt. The quilt right now is going to be the small rectangle on the inside of this. The quilt measures 4 feet by 5 feet. I know 4 times 5 gets me 20. So that's actually the area of the small rectangle, 4 times 5, or 20. So the end of my expression is going to be a minus 20. The area of the big rectangle, here's where people get a little stumped. The area of the big rectangle is going to be the area of this rectangle, or the area of this quilt, once I've added this border. All I know about the border is I want it to be the same width all the way around. So what I have for the new rectangle, currently it's 4 feet because it matches up to the quilt. But what I've done is I've added a little bit of border on this side, and I've added a little bit of border on that side. So this new entire length is going to be 4 plus 2x. 4, the width of the quilt right now, and then 2x because I've added that for both sides. Okay, so that's my new length or width or whatever you want to consider it, one dimension of the big rectangle. If we look at the height of the big rectangle, we're going to use a similar kind of thinking. That new height with the border added on is going to be 5 feet because that's what the quilt has now. But then I want to add a little bit more. I'm going to add a little bit this way, which is x. And I'm going to add a little bit this way, which is another x. So this entire side over here is 5 feet plus the 2 x's I added on to the top and bottom. That's usually the part that gets people a little stumped. So then to express the area of that big rectangle, the length and width, 4 plus 2x, and then times times 5 plus 2x. Would be the width of the big rectangle. And so multiplying those together gets me the entire area of the big rectangle. Remember, I want to subtract off that 20 though, because I'm trying to add a border. I don't want to include the border on where the quilt is already located. I just want this to go around. So that expression is going to be how I represent the area of this frame. Going back to the problem, it says that we have 10 square feet of material to use for the border. So this is how much area the border is going to take up. I want that to be equal to 10. So there's the equation I want to solve. Once you've got that set up, again, if you want to solve it by factoring, go ahead. You'd have to multiply out, get this problem equal to 0, refactor it. It's definitely doable, but to save time, once again, I want to show you how to solve this by graphing. So we're going to switch over and solve this using the graphing calculator. We're going to graph one side of our equation as y1. And we're going to graph the other side as y2, and then once we find a window that works, we're going to look for the intersection between those, between that line and that parabola. So let's switch over to the graphing calculator and finish this problem out.